Hi and welcome back to my channel. Today we're going to be looking at section 1, the multiple choice of the 2019 National 5 paper. Try this paper yourself and then use this video to help you mark it. For question 1 and 2, they both relate to the first sentence. The volume of gas collected in 2 minutes was 5 centimetres cubed. What was the average rate of reaction over this time? At the front of your data book, you will find the equation to help you calculate average rate. This is given as delta quantity, which means change in quantity, divided by delta time, change in time. The quantity you've been given is 5 centimetres cubed and the time is 2 minutes. This means we'll do 5 divided by 2 to give 2.5, which is C. The second question is looking at the unit for average rate. So again, using the same equation, you can work out what your units should be. You have delta quantity divided by delta time. The unit for quantity is centimetres cubed and the unit for time is in minutes. Here we have centimetres cubed divided by minutes. Now you can give units in this format, but you'll see that none of the answers are in this format, so we need to change it. So we have centimetres cubed per minute, which is min to the minus 1, giving the answer as B. For question 3, Tennessine is a newly discovered element with a predicted electron arrangement of 2, 8, 18, 32, 32, 18 and 7. In which group of the periodic table should Tennessine be placed? The final electrons, the outer electrons, are the ones which determine which group an element would go into. We have 7 outer electrons, therefore Tennessine should be in group 7, which is C. Question 4. Which of the following is a positively charged ion? To be able to answer this question, you need to understand the different subatomic particles. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. For a particle to be positively charged ion, it needs to have more protons than it does electrons. This means that the positive charge of the nucleus will be greater than the negative charge of the electrons around it. For A, you can see that we have 10 electrons and 9 protons. This means we have 1 more electron than there are protons, so this will be a negatively charged ion. For B, we have the same number of protons and electrons, so this will be neutral. For C, we have the same number of protons and electrons, so this will also be neutral. And for D, we have 12 protons and 10 electrons. This means that we have 2 more protons than electrons, so this will be a positively charged ion with a 2+ charge. Question 5. To turn a gas into a liquid, it must be cooled below a temperature known as its critical temperature. We have a table which shows a number of different gases, which are either elements or compounds, their relative atomic masses, and their critical temperatures. Identify the true statement based on the information in this table. Statement A, carbon dioxide can be a liquid at 40 degrees. This means that if we're cooling this down to 40 degrees, it will become a liquid. The critical temperature for carbon dioxide from the table is 31. This is the temperature at which we need to get to make it into a liquid. 40 degrees is higher, therefore this is not true. Looking now at statement B, compounds have higher critical temperatures than elements. So we need to identify compounds from the table. We have 2 compounds, ammonia and carbon dioxide. If we have a look at their critical temperatures, we can see that we have 133 for ammonia and 31 for carbon dioxide. These are indeed significantly higher than the critical temperatures for elements. Let's check the other 2 statements. Critical temperatures increase as relative formula mass increases. We have a look at the relative formula mass. You can see it's increasing from hydrogen at the top to carbon dioxide at the bottom. But if we have a look at the critical temperatures, we go from negative 240 down to negative 268, then up to 133, back down to negative 119 and back up to 31. So there's no pattern here. And then the final statement, diatomic elements have lower critical temperatures than noble gases. We have 2 diatomic elements, hydrogen and oxygen in the table, and then 1 noble gas, helium. If we look at the hydrogen and the oxygen, you can see that their critical temperatures are -240 and -119, whereas the noble gas is -268, which is lower. Therefore, that statement is also incorrect. So our correct statement is B. Question 6. A molecule of phosphorus trifluoride is shown. Which term can be used to describe the shape of a phosphorus trifluoride molecule? So the options we have are linear, which would be in a straight line, angular, which would be a bent line, tetrahedral, which would be with 4 different parts attached, or trigonal pyramidal, which is what we have here. It looks like a pyramid. In which of the following compounds do ions have the same electron arrangement? You may wish to use the databook to help you. So you need to use page 6 in your databook, which has the electron arrangements, to allow you to work out what the electron arrangements of ions would be. Remember that metals will lose their outer electrons and non-metals will gain outer electrons. So here in A, we have sodium and oxygen. A sodium atom would be 281. It would become 28 as a sodium ion. An oxygen atom would be 26. It gains 2 electrons to become 28 as an ion. So A will be our answer. Make sure you know how to do the rest just by checking through. So lithium is 21 and becomes 2. Fluorine is 27 and becomes 28 by gaining an electron. Potassium is 2881 and becomes 288. Bromine is 28187 and becomes 28188 when it becomes an ion. And then finally, magnesium is 282 and becomes 28 when it becomes an ion. And our chlorine is 287 and becomes 288 as an ion. So the answer, which has the 2 ions with the same electron arrangement, is A. Several conductivity experiments were carried out using the apparatus below. So we have a DC supply here, some electrodes in 2 beakers with substances that we're checking for conductivity. We need both of the substances to conduct electricity to allow the bulb to light. Our options for the substances are solid copper sulfate, copper chloride solution, solid potassium nitrate, and sodium chloride solution. These are all ionic substances. For an ionic substance to conduct, it needs to be either a liquid or in solution. This means that the 2 solids will not conduct, so this eliminates A and C. Looking at the other beaker, we have the choice of liquid mercury, molten sodium chloride, nickel bromide solution, or liquid hexane. We have a number of different substances here. We have liquid mercury, but this is part of A, so it's already been eliminated. Liquid mercury would conduct electricity. Molten sodium chloride, which is an ionic substance and in the form of a liquid, would conduct electricity. Nickel bromide solution would also conduct electricity. However, C has already been eliminated. And then finally, liquid hexane. Hexane is a covalent substance and therefore will not conduct electricity. This means that our answer is B. Question 9. Limewater can be made by dissolving calcium hydroxide and water. Which of the following terms correctly describes calcium hydroxide? You need to look closely at the wording of the question. Limewater can be made by dissolving calcium hydroxide in water. This means that we're making a solution. We're making the solution by taking the calcium hydroxide as a solute and dissolving it into the water, which is a solvent. This makes limewater, which is a solution. Therefore, calcium hydroxide can be described as a solute. Question 10. Ammonium nitrate NH4NO3 has a gram formula mass of 80. The percentage by mass of nitrogen in ammonium nitrate is equal to what? At the front of your databook, you will find the equation for percentage mass. This is equal to GFM of your desired element divided by your total GFM, all multiplied by 100. In this case, the desired element is nitrogen, and there are two of them. Each nitrogen has a mass of 14, so in total we have a mass of nitrogen of 28. The GFM of the compound is given in the question as 80, and then we multiply by 100. This gives B as our answer. Question 11. As an alkaline solution is diluted with water, what happens to either the pH or the concentration of hydroxide ions? This means we need to understand what an alkaline solution is. An alkaline solution has a higher concentration of OH- ions than H+ ions. This means that it usually has a high pH, which will be greater than 7. As you dilute the solution, you will find your concentration of OH- ions will decrease. This means that the pH will also fall as it goes down to 7. This eliminates both A and B. The concentration of your hydroxide ions is decreasing, leading to D as our answer. Question 12. Which of the following compounds is a base? A base is a substance which can neutralise an acid. Bases are metal oxides, metal hydroxides, and metal carbonates. All other substances with metals are salts. In this case, sodium oxide, A, is the answer. Question 13. Which of the following compounds does not have an isomer? For a substance to have an isomer, it needs to be able to have the same molecular formula but different structural formula. Cyclopropane, which has the formula C3H6, can have isomers in the form of propene. Butanene, which has the formula C4H8, has a number of different isomers, such as butene or 2-methylpropene. Pentane has the formula C5H12 and also has a number of isomers. Ethene, however, is C2H4, and there is only one structure possible for this formula. Therefore, ethene, D, does not have any isomers. The systematic name for this is what? The best way to tackle this is to draw out the full structural formula. Here we have CH3 joined to CH2, joined to a carbon, which has a CH3 branch, joined to a carbon with a hydrogen, and then a CH3. As we can see here, these carbons only have 3 bonds. Carbon has a valency of 4, so we need to put in a double bond to make sure that both of those carbons have a full valency. We then need to number this from the end closest to the functional group, which is the double bond. So that's numbering from the right hand side, to find our longest chain, which has 5 carbons. On the second carbon we have a double bond, and on the third carbon we have a methyl group. This leads to C as our answer. Question 15. When pentwanene undergoes an addition reaction with water, 2 products are formed. So here we can see that we have the double bond here on the pentwanene, and we're joining water. This joins in the form of an H joining onto one carbon and an OH onto the other carbon. Since pentwanene is asymmetrical, there is more than one option for how the H and the OH can join on. The H can join onto the first carbon and the OH onto the second, or we can have the OH join onto the first carbon and the H onto the second. Which of the following alkenes will also produce 2 products when it undergoes an addition reaction with water? To get 2 products, you need to have an asymmetrical alkene. To work this out, we're best to draw out the skeleton structure of the carbons for each of the answers. Oct-2ene has 8 carbons, and between the second and third we have a double bond. we can immediately see that this is asymmetrical. Check the others before finalising your answer. Hex 3ene, we have 6 carbons, and between the third and the fourth we have a double bond. This is a symmetrical alkene. Butene, we have 4 carbons with a double bond between 2 and 3, also symmetrical. And ethene, we have 2 carbons with a double bond, also symmetrical. Oct2ene is our answer, A. Question 16. In the Clemmensen reaction, ketones can be converted into alkanes as shown. A ketone is a substance which has a C double bond O somewhere within the chain. We can turn this into an alkane using this reaction. Identify the alkane produced if the following ketone was used in this reaction. What we need to do here is compare this structure to the structures given, also using this reaction to help us. What we can see is that where we have the C double bond O, this is replaced with the 2 hydrogens here within the alkane structure. For this ketone, we're going to replace the C double bond O here with 2 H's. We then need to find this structure within the ones given in the question. The structure has a methyl group here attached to 6 carbons. So here we have our methyl group attached to a chain of 6 carbons, making B our answer. Question 17. Which line in the table correctly describes the trends going from hexanoic acid to butanoic acid? So here we're going to draw hexanoic to butanoic acid. Hexanoic acid has 6 carbons. Butanoic acid has 4 carbons. Going from hexanoic acid to butanoic acid, you can see that we have a smaller molecule and therefore the formula mass will be decreasing. This can eliminate A and D. Since we have a smaller molecule, we're going to be increasing how soluble this substance is. This eliminates C, making B our answer. Question 18. 4 cells were made by joining silver to different metals. The cells produced the following voltages: 2.7, 1.1, 0.9 and 0.5 volts. The metals used were copper, zinc, iron and magnesium. Which voltage was produced in the cell containing silver and copper? You may wish to use the databook to help you. You're going to want to look at page 10 of your databook where you have the electrochemical series. Of the 5 metals present, silver is the lowest on the electrochemical series. This is followed then by copper, iron, zinc, and then magnesium at the top. The further apart the metals are on the electrochemical series, the larger the voltage that will be produced. If we make a cell between magnesium and silver, we'll get the largest voltage. This means that this would have been the 2.7 volts. The next one would be between zinc and silver, which would be 1.1. Between iron and silver would be 0.9, and between copper and silver would be 0.5. D. Question 19. Information about the reactions of 3 different metals, X, Y and Z, is given in the table. Which of the following shows the metals in order of increasing reactivity? If we start by looking at the reaction with dilute acid, we can see that both X and Z react with acid, but Y does not. This means that Y must be the least reactive. So we'll come first. This means we can eliminate B and D. If we look now at the reaction with water, we can see that Z reacts with water, but X does not. This means that X must be the next reactive, followed by Z as the most reactive, giving C as our answer. Question 20. A copolymer is formed when 2 different monomers polymerize. Part of the structure of a copolymer, showing 3 monomer units, is given below. One of the monomers used is propene. Identify the other monomer. First, I'm going to draw propene in the form of the monomer that we would usually see. This would be in the H arrangement, and we have 3 carbons. So one of the monomers we're looking for has this arrangement. We need to find the other. If we start at the beginning here and put brackets around the first part, the first monomer will be the first 2 carbons. We can put a bracket around that. We then have our second monomer, and then the third. We can see here that the monomer that's been highlighted in blue has the same arrangement as propene. This means that the ones highlighted in red are our other monomers. If we're to take the bonds on either side and fold them back in to make the double bond, we can see that we have a structure here of 4 carbons, 1, 2, 3, 4, with a double bond between 2 and 3. This means that our other monomer is but-2ene, C. Question 21. Nitrogen dioxide is a brown coloured gas that is soluble in water and more dense than air. Which of the following diagrams shows the most appropriate method for collecting and measuring the volume of nitrogen dioxide? We need to read carefully about the properties of nitrogen dioxide. It's a brown coloured gas, so we can see it. It's soluble in water, so we can't use any water as it will dissolve. And it's more dense than air. We want to collect and measure the volume of the nitrogen dioxide. We can't use anything that involves water, as the nitrogen dioxide will dissolve. This gives us 2 options. We can either have our downward displacement of gas or upward displacement of gas. As nitrogen dioxide is more dense than air, it will fall down into the cylinder and displace the air out. Therefore, C is our answer. Question 22. A solution of a metal chloride burns with a green flame. Which of the following metal ions could be present in the metal chloride? You may wish to use a databook to help you. You'll need to look at page 6 of the databook where you have the flame colours. We're looking for something which has a green flame, which you will find is barium 2+ ions. Question 23. Identify the gas that turns lime water cloudy. You're expected to know the different gas tests. For oxygen, it will relight a glowing splint. Hydrogen would burn with a pop, and carbon dioxide would turn lime water cloudy. Question 24. The reaction shown by the equation is an example of what? So in this equation we have 2 aqueous solutions reacting together to form an aqueous solution and a solid. This is an example of a precipitation reaction. An addition reaction would require an alkene, a combustion reaction would require oxygen, and a neutralization reaction would require an acid and a base. Question 25. Which of the following ions are spectator ions in the reaction? Spectator ions are those which do not get involved in the reaction. The ions which have reacted are silver and bromine, as they have formed the solid. This means that the sodium and the nitrate are the 2 spectator ions within this reaction. Thank you for watching my video. I hope that you found it helpful. Please remember to subscribe and ring the bell to be notified of new videos. You can also follow me on Twitter at MissAdamsChem and Instagram MissAdamsChemistry for updates on new videos and flashcards throughout the year. Bye for now!